Have you ever thought of sine of zero point 0.2? If you haven't, and now you are thinking of sine of zero point 0.2, how does your calculator know what sine of zero point 0.2 is? Because that's a pretty hard value to get. Normally, when you plug things into the calculator, you would be able to solve them in real life, but it just takes time. So that's why we use the calculator. But things like sine of zero point 0.2, I wouldn't even know where to begin solving that normally. Well, if you're interested in questions like that, you're in the right place. Welcome to Learning to Calculus, and today's topic is just a general overview of what calculus is. As a quick introduction and why I'm qualified to teach you some calculus, I think that math is fascinating. I just recently graduated high school and earned a 5 on Calculus BC, which is equivalent to Calculus 1 and Calculus 2. And I plan to teach calculus or some sort of math when I grow up and become an adult. And once again, the best way to improve at calculus is by doing calculus work. So calculus was discovered in the 17th century by two mathematicians. One of them, who you know, is Isaac Newton, and the other, who is slightly less known, is Gottfried Leibniz. They discovered and developed it at the same time, and during this time period, it was called the calculus of infinitesimals, or the study of infinity. By using limits, Leibniz and Newton were able to study things of infinite size or things that were infinitesimally small. If the one word can be chose to describe calculus, that word would be change. There's two types of calculus. There's differential calculus, which is the study of the rate of change, the instantaneous change, and the continuous slope of curves. And then there's integral calculus, which is the study of accumulation of change, of accumulation of quantities and area under curves or beneath curves. Calculus also has many approximations in it. As I mentioned at the beginning of the video, that's how you're able to get things like sine of 0.2. You don't actually find what sine of 0.2 is. You use calculus to make an approximation. So the derivative describes instantaneous change, but what is slope and what is change? Even in early algebra, many students are familiar that slope describes the rate of change between 2 points. This is f of x is equal to 2x plus 3. And by using this slope form that many people are familiar with, the rate at which y changes is 2 times greater than the change in x. Slope is calculated with this equation right here, which means that it is literally just a ratio or comparison of the change in y and the change in x. So when dealing with lines, slope is very intuitive to understand. That's why most people learn it in algebra. However, real life is not always modeled by lines. If you wanted to describe the slope of a parabola, the answer might seem a little more difficult to find. The slope of x squared is constantly changing. It never has the same slope at any point. So let's keep this slope equation as our starting point, but let's change it a little bit. This pink line just represents a random value x, and then this blue line represents x plus h. So that means it's just offset some distance from x. This is just 1 and 2, but it's just an arbitrary value. So this is what our slope equation looks like now. So it's f of x plus h minus f of x divided by x plus h minus x. So using that equation as our new slope formula, let's remember what Newton and Leibniz used limits for. So here's the big moment. We can use a limit and say that that distance between the 2 points, h, approaches 0. So now our new slope equation will look like this. The limit as h approaches 0 of f of x plus h minus f of x divided by h. As you see my note right here, the x's will just cancel out. This shows wonderfully what this process does. This point right here is x, and then when the GIF restarts, this is x plus h over here somewhere. There it is. This is f of x plus h. When that limit happens, the distance becomes 0, and that becomes the instantaneous rate of change. You can use just normal slope to find instantaneous slope. And here's where calculus gets even cooler. Derivatives describe instantaneous change. Integrals describe the accumulation of instantaneous change. So with constants or linear lines, finding the area underneath the curve is really easy. You just use rectangles or right triangles. But when the curve becomes more complicated, rectangles can still be used to approximate the area. Like I said, approximations are really important in calculus. With an infinite number of rectangles of infinitely small width, the area will become exact. That's what an integral is. So just like we did with the with the derivative, we're going to call the width of the rectangle, so this distance, let's call it dx or delta x. And the height of the rectangle is just given by f of x. It's the height of the function. So using a limit and a sum, where n is equal to the number of rectangles, you can add up an infinite amount of rectangles given by the area, which is literally just width, which is right here, times height, or length, which is right here. So calculus is all about change, which is really cool, but it's really hard to understand why that's so important. They are connected to each other so closely, in fact, that what's called the fundamental theorem of calculus shows that integrals and derivatives are opposite processes of each other. And then the second part of the fundamental theorem of calculus describes how things accumulate and why that's important. Calculus describes speed, velocity, acceleration, time, distance, area, accumulation of quantities of anything. And it can be used how things change throughout a period of time. That's why calculus is so important to things like physics and chemistry and engineering. In real life, things change and accumulate all of the time, which is why calculus is not only so important to the world, but also so beautiful, because it describes our world. Learning calculus is difficult. There's a lot of work that you need to put into, especially when you start getting to things in calculus 2 and really difficult integrals in calculus 1. But overall, learning calculus is not only super rewarding, it's beautiful.